Good day and welcome to this video in the series on C#.NET for engineers. In this video we're going to continue with the big picture concepts, and specifically we are going to look at the code and file structure within a Visual Studio solution. Now I'm going to assume that you've watched the video that came just before this one, in which we spoke about the project types that you can have in .NET C#. And we also created there a console project and an associated library project. And in the hands-on work that we're going to do later in this video, I'm going to assume that you have followed along with that previous video and you've got those two projects in a Visual Studio solution ready so that we can continue working on that. So if you haven't watched that previous video first, then I suggest you do that now. Okay, so let's look at code structure in a C# solution. So if you have followed along with the previous video, you will know that we basically, within a Visual Studio project or solution, the largest container, which contains everything that you put into that, is called a solution. Right, so if we look at the hierarchy of files and concepts within a Visual Studio project, the solution is the broadest concept that we can have. Within a solution then we have a project. For example, in the previous video we created a console application called My App, and then we also created another project called My Library, which was a class library, and that project also sat in the same solution. Right, so there you see the containing object is a solution, and within that we've got two projects. Now and we also showed that the library was referenced from My App, so that My App could use the code aspects, methods and tools, etc. that was contained in the class library project. Now the next concept that fits within a project, which you may not yet be familiar with, is what's called a namespace. And a namespace is basically a conceptual container for you to group your code into. So I'll show you later how you actually declare a namespace, but think of a namespace as a subfolder, and you can put your class files and other code objects within a certain namespace, and then they will be constrained to that namespace specifically. So let's say we have in our console application a namespace called main, and within that we then have a class 1 and a class 2. So these are file objects, and we'll discuss that later. And then let's say we've got another namespace called utilities, and in there I've also got a class 1 and a class 3, right? So notice that I've got two classes called class 1, and that is okay because they are in different namespaces. You cannot have the same class name within the same namespace, or if you're not using namespaces, if your classes are just sitting without any namespace, you cannot have the same class name repeated twice, right? So the namespace is basically distinguishes is a level up, right? And similarly, if you think about Windows Explorer, within a subfolder you cannot have two files with the same name, but you can have a file with the same name sitting in two separate subfolders, right? So think of namespaces as if they are subfolders. And we've got the same thing in the library. Well, let's say we've got a namespace there called file ops for file operations, and maybe another namespace called math ops. And as you can see, these namespaces are names that you will be choosing when you write your project. And it's very important to think about your structure of your project and choose namespaces which will logically explain what is the objective and the uses of the code that sit inside that namespace. There are many different ways in which you can slice and dice things. For example, you can put more code in one class or more classes in one namespace. You can also decide whether you want to put everything that we see here. Maybe you decide, no, I'll just put these two namespaces inside this project as well. So it's almost as if you are organizing a home. You can pick whether you want to have one cupboard which has got many little drawers, or where you want to have two cupboards with two large drawers each, and within that you put all your clothes or something like that. So you basically within these concepts, the solution, the project, namespaces and classes, you really have a very flexible way of organizing your code. And this is quite important, because if you are writing some tools or things for yourself in C# that you want to use within your organization or for yourself, or maybe you are even thinking of writing a commercial application, you have to think about maintaining that code, and naming things correctly and wisely is a big element of a successful project as your project grows over time. Now let's see, I've explained now these concepts in conceptual, in the way of talking about them as if they are containers. Let's think about them as files, right? So if you think of this structure that I've just explained, how does that map to files? Well, first of all, we have the solution. Now a solution is basically, in Visual Studio, is just a single file. So it's basically just a file that contains, it's almost like a library index that explains how your projects are structured within that solution. So that's just a single file that sits in the first project that you add in that folder. You can move it, but by default, as I showed in the previous video, there's a box that you can tick that says put the solution file in the same folder, right? So you normally would find that in the first folder of the project when you create a Visual Studio solution. Next in the hierarchy, we've got the project. So that's the blue here, or the orange here. So that is basically a folder, and inside that folder you'll find a file that maps to the name, so my library or my app, and then it's got the extension CS project, CSPROJ. And there's one file like that inside that then contains the information about that project. Next, we've got namespace. So namespace is basically just a subfolder within the project folder, matched to the name at the top of a class. Now I know that may not completely make sense to you, but we'll explain that shortly when we go to the hands-on exercise. Now I just want to say, you don't have to have your namespaces to match subfolders exactly. You can override that by just typing a different name at the top of a class. But it's good practice, and Visual Studio will prompt you to, when you move a file into a different subfolder in a project, it will ask you, do you want to change the namespace? And that's normally good practice, to keep the namespaces consistent with the subfolders in which those class files sit. Right, then you have the class, the .cs project, the .cs file, and that sits within a project or within a namespace folder. And that is basically the foundation. Classes are the foundation of most of what you will do in a C# project. Then there are functions and methods, and this is basically just the C# code, and that fits within a class. So later videos we'll look a little bit at the syntax of these functions and methods and how they are structured within a C# code or class. So this gives you sort of a mapping of how these things actually will end up looking on your hard drive in your computer if you think about this conceptual project structure. All right, then also it's really important to understand that this structure is very important because it has an impact on how you actually reference things inside your code. So for example, if you are in the My App and you want to reference class 3, now note class 3 sits here in the project My App, and it's inside the namespace utilities. Well, then you will refer to it as myapp.utilities.class3. So this is like an address. It explains to you where this class 3 sits. So let's look at another example. How do you reference the method or the function read data in class 2 of the project My Library? Now here's class 2. It sits in the FileOps namespace, and it sits in the project My Library. So to reference a method inside class 2, let's say the method is called read data, we will be referencing it like My Library, that's the project, FileOps, that's the namespace, class 2, that's the class, and then finally read data with brackets, and if there are parameters to pass, it would be passed into those brackets. That's a way you reference it. Now, obviously, if you have to call a method or a variable inside this class repeatedly, you don't want to type all of this out all the time. So a shorthand that you can use is basically to avoid having to type this full reference path to a class or method. You can put the word using at the top of the class in your CS file. For example, at the top you can say using mylibrary.fileops, and that means that you can then, you don't have to put this first part in your you don't have to put this first part every time you refer to this method read data, right? So this allows you to access all methods inside your library, inside the fileops namespace, provided those methods are marked public, right? And that relates to the word that you will often see in the code that we are going to do shortly will contain it's called modifiers such as public or private, and they are very important to determine what can be seen where throughout the solution. And we'll have a separate video dealing specifically about these modifiers and the scope of variables and classes inside your solution. Okay, so let's go to hands-on demo and practice and add these namespaces to our project that we created in the previous video. I just want to clarify one thing. Because this project, My App, is a console application, it will always have a program CS, and that program CS will sit at the top of the structure of that console application. So that's not going to be inside a main namespace, but we will create a main and a utilities namespace and put these classes in there, and then we will, in the end, we will see how we can call these different classes in here from this program.cs. So let's head over to Visual Studio and we'll put this to practice. Okay, so I've got Visual Studio opened, and here at the top is the app that we created last time. Notice that it shows a solution, myapp.sln, that's a solution. So if I open that up, I can see the program.cs with the code that we created last time. And here on the right, in my Solution Explorer, you can see the structure of the project just the way that we created it last time. Now notice, if I go to this calculators class that we added, I put this in namespace calculators, right? But I don't have it in a folder, a subfolder called calculator. So that's what I said earlier, that you don't have to have namespaces mapping exactly to subfolders inside your project, but it's a good practice to do that. So we are going to correct that later on. So let's go over, and what I want to do first is go into My App, and I'm going to create two subfolders for those two namespaces that we want to create inside My App. So the first one, I right click on the project, I go to Add, and I go to New Folder, right? There's the folder, and I'm going to call that Main, right? And I use a capital letter at the beginning. That's normally the convention that you would use. And just take careful note, if you don't know it already, you will learn it soon, that C# is case sensitive, right? So that's the first namespace. The second one we called utilities. So we're going to go again, right click, go to Add, and go to New Folder, and I'm going to call this Utilities, right? And now I'm going to add inside this, add a class, right? And I'm going to call that class 1. And if you look here now, you'll see that it has put for us some default using statements here, and then also it has namespace myapp.main, right? And so that's the namespace. Now you can see that the class sits here inside of the namespace, and there's these little squiggly brackets there that contains that. Now in C#, if you put a semicolon at the end of your namespace, it will remove these brackets. So that'll be a top level namespace. So I'm going to do that. Just do it like that. And now you can see this implies that what follows below sits inside that namespace. So I've got this class 1, and here you can see the keyword internal, right? And so at the moment, don't worry too much what that means. All I want you to do is just double click on that and just make that public, lowercase public, right? And we'll put one method in here, right? And this is going to be a public method. It will be seen everywhere. And we will return a string from this method. And I will say this method is called getHello. And I'm going to return hello from my app.main.class1.getHello. Right? That's what I'm going to return there. And now I'm going to add another class called class2, and I'm going to do the same, and that also goes into the main namespace. So this is a bit boring to watch, but it's important for you to get this practice in. So again, there's a namespace with the brackets. You can use it like that. I like to put a semicolon there to remove those brackets, and then I'm going to make this a public class. And I'm going to go again, see my GitHub Copilot has just completed for me, auto-completed there. It guessed what I wanted to put in there. So I'm just going to press tab to accept that. It's likely that you won't have GitHub Copilot available, and that's fine. Just type this out. And you can see GitHub Copilot very cleverly has seen what I want to do. So I've got my app, hello from my app main class 2. The other one was class 1, getHello, right? And so those two, and notice there I got this asterisk at the top. That means there's some unsaved changes in that class. So there's two save buttons in Visual Studio. One saves the file that's currently open. The other one next to it saves all the unchanged changes in all of these files. So I normally just click on that, right? And then I go again to Solution Explorer, and I'm going to go in Utilities, and I'm going to add another class in there. And this is also called class 1, right? And again, I put the semicolon to remove these brackets. I change this to public. And there is my method, hello from my app utilities class 1 getHello. And now I want to add one more class there, add class. So this is good practice, and this one I'm going to call class 3 just to go with our diagram. Again, so let's just go and look. This is the diagram. This is what we want to create. So we've got inside project my app, we've got a namespace main and a namespace utilities. We've got a class 1, a class 2, and then another class 1 and a class 3. Right, so this is my class 3. So again, I put a semicolon at the end of my namespace. It removes the brackets, and I change this to public. There is a way to configure Visual Studio so that when you create a new class, it will automatically do this as an option to put a semicolon there and remove the brackets. And you could also set it up so that it will automatically make your classes public and not internal. Again, I'll explain later what public and internal means, the implications of that. So there is a way to do that in Visual Studio. That's maybe an exercise you can do for yourself. I tried once to follow some instructions. It didn't work, and now I just do it myself every time. Okay, so I go and click on Save All. You can see I've got this asterisk there indicating that there's unsaved changes. And now I can just see if I click on Build and I click on Rebuild, it's going to compile my solution for me, right? And so if I do this, you can see at the bottom it says Rebuild All Succeeded. That's what you want to see. And I recommend as you work, whenever you code, don't go too long before trying to rebuild when you've made some changes. Try to, as you finish each little code concept, try to rebuild and make sure that you don't do a lot of code and then there's a lot of bugs in it. Now, remember I said earlier that it is okay for you to have two class 1s in your project, provided they are not in the same namespace. And so you can see if I try to add another class here, and I want to name this class 1, Visual Studio will say a file with class 1 is already exists and is open in the editor. And so it won't allow me to do that. So basically that's just like you would get if you're using Office or any file that you want to try and put in Windows Explorer in the same folder, right? And so now we can go and do the same in the library, and this time we want to follow this structure. So we're going to have a namespace called File Ops and another namespace called Math Ops. And we want class 1 and 2 in File Ops and class 4 and 5 in Math Ops. So we go now to the library project, and I'm going to add a new folder, and this I'm going to call File Ops, right? And I'm going to add another folder, add new folder, and I'm going to call this Math Ops, right? And inside here I'm going to add a class, and that'll be class 1. Again, this is good practice. It's boring, but good practice. Semicolon, change the internal to public, class 1, and there's the get hello that GitHub Copilot adds, and you can see now I've got hello from my library, File Ops, class 1, get hello, right? And then I'm going to add, let's see, I want to add class 2 here, then class 4 and 5. So I'm going to add another class, class 2, semicolon, public. There I got get hello from my library, File Ops, class 2. Again, see the asterisks, I save all, and can you see that I've got quite a lot of tabs open here already. I normally don't like if there's too many. It's good if you want to look at one class and then another one. So you can just go Window, close all tabs, and you got it open. So you got it. Then you got those files removed. So now we got to go and add class 4 and 5 in the Math Ops namespace of my library. So I'm going to Math Ops, add class. This is going to be class 4, right? So take note that the name of the class, the name of the file that you add here matches the name of the class. So if I click on this, there's class 1, and I go over here, that's the name of the class. You don't have to have that correspondence. You can actually call this class something else, but it is a very good practice for you to have the class name correspond to the actual class that's contained in there, right? You can also have more than one class in a file. So you'll see if I go in here at the bottom of this class. So for example, if I go public class test and I do that, then this will compile. If I go build, rebuild solution, see at the bottom here, build succeeded. So here I've got two classes in one file, class 1, and class 1 matches the name of the file, the actual file. And then I've got another class sitting in the same file. Sometimes you will do that. You'll see often if you go to ChatGPT and ask it to write you, to give you a solution, it will do it like that. I don't recommend you do that. There are some instances when you may want to have several classes, like for example, some things called enumerations. I like to put them all in one file. And then you may have more than one class in a file. But generally, if you've got enough code to substantiate why you want a separate class for it, it's best to put it in a separate file as well. Right, so I'm going to delete this test class here. And I'm going to go to Math Ops, and I want to add, I got to add class 4 and 5. I don't know why I skipped class 3, but there it is. So I'm going to add a add class, and this is going to be class 5. And again, good practice, semicolon at the end, change this to public. Copilot will help. There's my get help method, and there's my get hello from my library MathOps class 5. So now that we've got all of that, we can go back to my app, and we go to the program.cs file. Right there it sits. You can see it's not inside one of those namespaces. And now what I want to do is to call some of those methods that we've got in the different namespaces. So I'm going to delete this code. And in here, I'm going to just say, let's start with methods inside the library. So I'm going to say my library dot. Can you see how Visual Studio helps me? If I press the dot, it shows for me the namespaces inside of that library. So let's go to FileOps, and we say class 1. Now we have to create an instance of that class, right? So an instance basically means that at runtime, the compiler will be such that there will be an object created in memory which represents that class. Now, this could be very confusing because you can see here I've got the word class 1, but then I've got the variable as well called class 1. And you very often get confused between the name of the class and the variable, the instance of that class that is open in memory, right? Specifically if they've got the same name like this. So I'm going to call this something else just to clarify that for you. So I'll call this class 1 instance, right? So it's an instance of class 1, and you have to use this syntax, new, to tell it I want to create a new object that is in my library FileOps class 1. Now that we have that class instance created, I can say console right line class instance get hello, right? And let's do that also for another class, and let's do MathOps. Okay, so there I've got class 5, class 5 instance, and I can also say console right line class 5 instance get hello, right? So let's do another one. Let's call in the my app, so not in class library, but in my app, let's call the method inside class 3 in the utilities namespace, right? So we go here and we say my app dot, again, Visual Studio help me. I want to go into the utilities namespace, and I want to use class 3. And I want to create a class 3 instance. Again, I can make this anything. I'll just use my name, Fritz, right? And so I can create an instance called Fritz, but the instance represents a class 3, right? So I'm going to say Fritz dot I think that I have not in this class 3 added the method yet. So let's go to, see, I didn't add the method in there. So if I go here and I go put my get hello method, now I can call that from fritz.getHello, right? And now let's run this. Before we run it, just think about what this is going to show. Each method that I'm calling, I'm going to call them one after the other. Each one calls get hello, and they are going to look the same, but they will contain differences to show where the code is being called from, right? So I'm going to save all, and I can now run this app. And there you can see I've got hello from my library FileOps class 1 get hello. So that's this one here, right? And then I've got another one from class 5 instance, hello from my library MathOps class 5 get hello, right? But can you see here, because I just said fritz.getHello, I didn't write this out to the console. The app ran, but that variable in that string variable, that message that came back, it was not plugged in anywhere. It was just returned. Nothing was done with it. And so, but whereas with these two, I said console.writeLine, so I actually wrote it out. So let's modify that. So I'm going to just close down this app, and I will say modify this to say, and I'll do that. And now I should get 3 lines coming back. There I've got them. Hello from my library fileops class 1 get hello. Hello from my library class 5 get hello. And also hello from my app utilities class 3 dot get hello. Okay, so that shows you how you would reference that. Now you remember I said earlier in the presentation part, I said here that to avoid having to type the full reference path, you could put using at the top. Let's just do that. So here I've got my library fileops class 1, right? So if I do this and I put at the top using my library fileops, right? Then you see Visual Studio grays this out, right? It's there. If I run it, it will still compile. That's not a problem. But Visual Studio is graying it out, and because it's really unnecessary because I've got this at the top. So if I remove this and I just say class 1 like that, then the code will still compile because I'm using that at the top. And I can do the same with my library MathOps. So I can say using my library MathOps. And I can also say using my app utility. So now I can take these away. I don't need that anymore. Okay. However, we can see I've got a problem here. You see the red underlining there. Now why is that there? Because it is saying in my app utilities, right, I've got a class 1, and in main I've got a class 1, and this is confusing the namespaces. So I have to qualify which class 1 are you talking about. Are you talking about the one that is in utilities, or are you talking about the one in main, right? So in this case you will want to put let's say utilities dot class 1 equals new utilities my app dot utilities class 1 equals new my app utilities class 1. Right, so now this is unambiguous. We know which class 1 you are talking about. Okay, so you can see that it could get confusing if you have different classes with the same name in different namespaces. For that reason, I would actually recommend that you avoid classes with the same names. And in any event, hopefully you are never going to create a class called class 1. The name that you give to a class will almost always represent what is done or what that class actually is for, right? So a class would be called something like file manager, right? File manager or data controller or something like that, right? And you'll see if I go and I rename this class here, so I can right click on the file. So note I'm renaming a file physically on the drive. I'm renaming it. So if I go to rename and I call this data controller, so you can see I'm using camel case, and typically a class would start with a capital letter, so data controller. Now note if I go here, you'll see that if I enter that, then it will ask me, you are renaming a file. Would you also like to perform a rename in this project of all references to the code element class 1? You say yes, right? And now you can see that this class 1 in utilities is still called class 1, but this one is called data controller. And if you go to the actual class, you'll see the name of the class was also changed to data controller. So if I go back to program file, and I now go and create a class that is a data controller, then I can say main dot let's call it my app main data controller, and I'll call it controller equals new data controller. So the instance name is called controller, and I'm going to say console write line controller.getHello. Now notice that I've changed the name of the file and the class to data controller, but if I go to this method here, it still says class 1, right? And so that could be confusing. Let's just copy that and paste it in there. So now this says hello from my app main data controller get hello. So see, I've got my asterisks next to several of the files here. So I'm going to save all and then run this. So there it's opened, and I've got my hello from my utilities class 1 get hello, and at the end here I've got my app main data controller get hello, right? And so take note of these files here. That's basically the way that we've created it, and that's the way that you will structure your code. So if you go to ChatGPT and you ask it to solve some sort of a problem, typically it's going to put the code inside a class, and that code you can copy and paste inside of a file such as this one, and then you can start making use of that. Now the last thing that I want to look at is just the file structure on the disk. So that's also something that's familiar to you. So I have put this project here in ZZ Demos, and if you look at this file structure here, you'll see I've got inside ZZ Demos, I've got my app, and if you look there, you'll see there at the top is the solution. There's the CS project, right? And then inside I've got my folder utilities, and you can see there's my class files. Under main I've got class 2 and the one I renamed data controller, right? And you'll see there's my program CS. If I go to my library, you'll see there's also MathOps. There's the classes that I created. FileOps, there's the files I created. Now you'll also see that both my app and my library has two other folders. One is called bin and one is called object. Right, and inside of those folders you'll see lots of files that you don't really know what they are. So we'll talk about that shortly, what about the object folder. But the key one is we go to the My App. Remember, My App is the application type that can run. If you go there and you go in the binary folder and you go into debug, you'll see there's a .NET 9 folder, because I remember when we created the project in the previous video, we assigned this as a .NET 9 project. So you'll see if you look in there, you've got your exe file, you've got a DLL file, and there's your library.dll. If you go to the library and you look in the bin file, now bin stands for binary. That means this is actually what the Visual Studio creates when it compiles the file. And if I look in here in binary folder and I go into debug and I go into .NET 9, you'll see there's only a DLL. There's also a PDB and a JSON that describes things about the project, but all you really need is this .dll, right? But if I go to the main app, the one that can run, and I go into binary and you look in debug .NET 9, then you'll see my library is automatically copied in there. And the reason for that is because remember that the top level app, the one that can run, references the library. And so because Visual Studio recognizes that this one references that one, it will package all of the required files inside of this binary folder automatically, right? And so if I double click on this, the app will run. So if you're writing your app and you want to distribute it for other users, there's only one thing you need to give them, and that is this .NET 9 folder. You can rename it as long as these files are in there. And these .pdb files you can delete. They are not really needed. If I double click on myapp.exe, it will actually run, right? I'm just going to go into this program file and I'm going to put console.exe read line to make it stop at the end, and I will just test it. Right, and now I have to press enter to close it. And now if I go to this and I double click on that, it will run. Right, so I double click on exe and it runs it. And now if I press enter, it will close it. I go again, double click, and it runs. Right, and so this is really all you need. You just need to give these DLL and exe files. Now you may say, why is there a myapp.exe and a myapp.dll? Right, and so this is what I'm going to ask you to do for homework. So for homework, what I want you to do is to ask ChatGPT what is in the .obj folder, or what is in the obj folder of a .NET project. And I want you to just study very carefully what it says, and also ask ChatGPT, I have a .NET console app called myapp. When I compile it, the bin directory contains both a myapp.exe and a myapp.dll. Why is there a myapp.dll file if there is already a myapp.exe? So ask ChatGPT to answer those questions for you, and take careful note of the answers. Just read it and get yourself familiar with those concepts. You can also ask it about the other files that are in those binary folders, the one that is not a DLL or a exe, so you just understand what the purpose of those files are. So that's it for this video. In the next video, we are going to go into that C# class that we created into some of them, and we're going to look more carefully at the structure of a C# class, and we will look more specifically at something called variable scope that deals with those modifiers, such as the ones that we changed the class scope from internal to public, and we will just discuss that in a little bit more detail. So that's it for this video. I'll see you in the next one. Thanks for watching.